Alright, today I got about a 60 or 70 hour project here to show that relates to the A7, and I'll show you what sparked this. The bar displays in this A7 are probably not the greatest bar displays I've ever seen, and they're pretty dim, so I was kind of thinking, what would it take to get these out of there and build another bar display board for it. And it's turned into quite a chore. There is a bunch of clips, 2, 4, 6, 8 clips that mount these through these cutouts, and these clip up against the front face. And that's probably the first difficult part, because the clips are square, and it's hard to duplicate things that are square. So what I did, before I'll show you the end result, is a little trick that I started doing many years ago, and it generally works out pretty good. Something that maybe some people wouldn't think of, I don't know. If I have a bunch of points that I want to basically transpose onto a circuit board, like the case here, what I will do is I will take heatsink compound and put a little tiny bit of heatsink compound over these edges right here, as perfectly as I can. And then I'll take whatever I want to interface with that and press it up against to make marks on that board to transfer all these points over onto a circuit board or whatever else you may be using. So this is what I came up with. And like I said, the problem was I couldn't do square cutouts here. And I thought, this is probably never going to fly, because best case scenario, I can get the holes aligned, but they're going to have to be circular. But strangely, it worked out so well, I'm still kind of amazed over it. So what I did was just take the heatsink compound marks on here and kind of judge. You had to look at the front clips and see which way the edge of the clip went, and then you had to compensate or shoot your hole in a certain direction to get the long edge of the clip. I'm just not even really sure how to explain it, but basically what I came up with is this here layout. It uses 12 Lumex LEDs on each side, which are around 10 to 15 MCD, and I'll show you how it interfaces here. So this is what the back has turned out to be so far, and honestly I am completely out of space on this. I literally don't even think I can fit, after I get onto this, the things that I need to. If that even happens, I don't think at that point I'm going to be able to even fit one more resistor on this board. I just have it completely maxed out. And that's something I often encounter when I build things. So my concerns was this. This was an ideal circuit board. Honestly, it's junk. And I didn't want this circuit board to warp. So I thought, what's the best way? Because I didn't want those LEDs to eventually go askew in the viewing window after a couple years. So I thought I'll run this stiffener board down the length of it and solder it the whole way down across to true up the face of this and keep it perfectly flat. So that turned out to be a good idea. Just unfortunately, I should have pulled this board back maybe just even 1/10 of an inch more on the width, and things would have been a lot easier. So it has two IR 2406Gs on it, which are going to be adjustable intensity. I don't have the control circuitry on the board yet for them. It's got two 5-volt read relays. It's got the audio rectifier chip, the 7818 I think it is. 13-volt regulator, and a bunch of resistors over here in a network to set the power level. And how that works is the 0 dB reference point for full power on an amplifier would be this LED right here, the next to the last red, as it works out to be on this one anyway. So at the 0 dB point, this red light on, given the power output of the A7, we want 50 watts to trigger this red light here on. So there's actually two different sets for two different power levels in these resistors, and they are switched in and out by these relays. So essentially what I will have is a high and low power switch like Sansui typically does. So I did the same thing on this. So on the ×1 scale, it will be 50 watts to here, and on the ×0.1 scale, it'll be 5 watts to there. So what I'm going to do is pull these relays down through a switch on the front panel, and dub that switch as being the meter range switch. And I didn't get the LEDs wired yet. That's going to be incredibly challenging. Didn't get the dimmer controls on yet, or the calibration controls, but that's where that's at. Now it sits in here pretty unbelievably well. And what I wanted to do was make darn sure that those LEDs are running as absolutely true as I can get. So what I did was I measured them off the inside top edge of this sheet metal down to the center of the LED. And then I cut this board so this board runs true and flush to the front edge, top inside edge of the sheet metal. So this board butts completely up against it, absolutely even. And you can see it sets right in there. It doesn't actually clip in so much, but it stays there very true until I come up with a fastening method. You can see how incredibly true that is. And it may need tweaked a little bit depending upon whether or not the board's pushed the whole way back, and the board actually might not be 100% seated where it needs to be right now. But just eyeballing it here from where I'm looking at, it looks fairly perfect. Actually, I anticipate having to probably do some blacking, maybe blacking on the circuit board, blacking in between the LEDs. I'm not sure what that's going to entail yet. I'm going to have to kind of run this and see what the whole thing's going to look like with the backlighting and this and that. But I'm pretty certain that there's going to have to be some blacking done somewhere. I think this project's going to work out pretty good, and I'm just going to keep going at it here until I get it done. Appreciate you watching. Have yourself a wonderful day.